rises temperature, why haven't overnight desert nighttime temperatures gone up in the last 50 or 100 years? They haven't.
Yeah, so I had this argument with, and we're going to a training course on retrofitting old buildings in November, and I can't wait because the chair, I had a sort of a bust up with the chair, and she sent me this like temperature map of the globe with the hottest temperatures ever recorded. And she said, "Look, the Earth is boiling. People are dying." And I'm like, "Whoa, stop being so alarmist." And then I brought this up a few weeks ago, and then I'd look at the dates on the hottest temperatures, and some of them went back to 1915.
That's right.
And then I went to the Vostok station, and the highest temperature recorded there was in 1976. It's just if it just falls apart. It's like, come
Right.
on, where's your argument now?
Right. Right.
And how many people are dying, by the way?
Yeah. Right. Splashing red on maps is not science.
Yeah. Yeah.
Right. So the better question is, have overnight temperatures gone up in the last 70 years and where? And the answer is, well, in the urban areas.
Yeah, sure. Urban islands, for sure.
In the northern hemisphere to some degree, because we've had 65 years of AMO increase, which is about to start going back down. We're at the peak of sunspot cycle 25, so you can expect 20 years of that. We've got lower albedo, so we got more incoming solar radiation. So sure, but in a lot of places like the poles, specifically Antarctica, and in the tropics, nighttime temperatures haven't gone anywhere. In the Arctic, yes, and that's the Arctic effect that Javier talks about in the book. It's a feedback cycle that will probably be turning back down as soon as the AMO starts going the other way, but only in very specific places.
But David, I'm really fascinated by that fact that in the deserts, the overnight temperature has not gone up over the past several decades. Is that absolutely a fact? Is it demonstrated somewhere?
Go look. Go find the data. Let us know.
Yeah, I didn't know that. That's sure. A very convincing argument, isn't it?
Keep in mind, if a desert gets more cloudy, that will increase temperature. So if you got more clouds coming in a particular year or dozen years or 20 or 30 years, then that'll increase nighttime temperatures for sure. So the details matter per desert. Some deserts are very high. Some, the top of Mount Kilimanjaro is a desert, essentially, right? And it's, and it doesn't have warmer nighttime temperatures. What it has is less water coming in from its normal sources. And that's why the ice is always sublimating at a place like that. It never melts at the top of Kilimanjaro. It's always sublimating away. And if more water doesn't replace it, then you'll get less ice. Nothing to do with temperature at all. So every area and every desert and has its own considerations. But please, if you have any spare time, give us a report on desert nighttime temperatures. I think we'd all be fascinated by that.
Yeah, I think Vostok versus the Sahara Desert, two nice extremes there.
Yeah, I talk about them both in my video, and they're both very dry. But remember, when it's very dry, the CO2 greenhouse effect is less than the H2O greenhouse effect, even though it's very dry. You can't say there's no water vapor. There is, and it actually does more. Has more of an effect on temperature than even the CO2, even though it's very low. And why? And one of the reasons is its parts per million, is pretty low, right? So CO2 is far less than 1%, and 1% water vapor is very dry. Yeah, but it's 500 times more than the CO2 on a molecular basis, right? Plus water vapor radiates a photon every fifth of 5 times a second, whereas CO2 radiates one every 0.6 of a second. So these things are a bit hard to compare, but at below about 9,000 feet or so, water vapor always trumps CO2 as a greenhouse gas. Above, 12,000 feet or whatever, CO2 generally trumps water vapor.
Forgive me. Could I ask what ice sublimating means?
Dry ice. Have you ever seen dry ice? It just turns into a vapor. It doesn't melt.
Okay.
Right? It goes from solid to vapor within a straight transition without going through water. And that's what happens in high glaciers. They never melt. It's too cold. It never gets above freezing. And there, if you could think about some places where there's sunshine during the day, might heat up a bit of ice and it might trickle some water. But in general, if you study high mountain glaciers, they sublimate. They don't. There's never warm enough to melt any ice.
Thank you.
And so they waste away by giving off water vapor rather than transitioning through water.